Greetings everyone. Today we are going to explore solving radical equations. Make sure you have your notebook ready. We might not have a foldable for this, so if not, just jot these down in your notes. All right, let's review some of our past information. You have been solving equations for so many years, and you know that to undo adding, you subtract, to undo subtracting, you add. Similarly, multiplying and dividing are inverse operations. And what we're really going to work on is the opposite of square rooting is squaring, and the opposite of cubing is cubed rooting, and so on. And so we're going to get used to these two inverse operations. And then we are going to work towards, not necessarily in this video, but reciprocal fractions, which will be our next video. The key thing we need to remember, and this is so important, is you must check all of your work, check your answers, because we are in a situation where we could end up with extraneous solutions. So take a moment to jot this equation down in your notes as needed. We're going to take care of inverse operations. Now you've solved very similar before in the sense of I need to isolate my function first. So everything under the cubed root has to stay. We need to do the algebra 1 work before we do the algebra 2 work. So algebra 1 work says let's undo any addition or subtraction first. Drop down what we didn't use. Undo any multiplication or division next. You need to isolate the function first, okay? So again, algebra 1 work first. Anybody could do that. Now let's take a look at the algebra 2 work. This is what's new. The opposite of cubed rooting is cubing. What we do to one side, we do to the other. That eliminates our radical, which leaves us with the radicand and a new value on the right-hand side. Instead of subtract 3, now we're going to plus 3. Then we do the inside work. And what's nice about this is you know if you are correct or not. Let's plug it back in. If I was to take a look and plug this in for my x, right? Inside first, this would get me 8. Cubed root of 8 is 2. 2 times 2 is 4. 4 plus 7 is 11. And that's what it says it should be. And so I know that I'm right. What if both sides are all cubed root? The cubed roots are isolated. So this is actually easier than you think, because to get rid of a cubed root, you cube both sides, right? Well, if I cube both sides, they both cancel. Super easy, right? So I arrive at the radicand equal to the radicand, which in itself is usually a super easy equation. So show as much or as little steps as you need to, but we should arrive at a -4. Now, you still want to check your answer, right? So if I plug in a -4 on the left side, that would be a -8 plus 3. That would be a -5. I don't even know what that is, but it doesn't matter. Because if I plug it into the right side, -4 minus 1 is also a -5. And I can cube root a negative. And the cube root of 5, whatever that crazy decimal is, would be the same on either side. So I know that I'm correct. All right, let's talk about squared roots. Now, the root is isolated. The root is isolated, so we are jumping straight into algebra 2 work. So to get rid of a squared root, we need to square both sides. That eliminates the radical symbol, and we arrive at a 7x, or the radicand, plus 15, but take a look at that right side. Excuse me, the left side. When we have a quantity squared, that means it's times itself. Let's see what that gets me. X squared shows much or as little work. I'm going to jump ahead a little bit here. So now we're solving quadratics. Oh my gosh, let's go back to first semester. We need to move everything to the left side to see what kind of polynomial we get. we need to have is equal to 0. So I've got a negative 5x and a negative 14. What does that look like I need to do next? Correct, we do need to factor. Easy factoring though, right? We're dealing with 7 and 2, factors of 14. That can get me to 5, so it'd be a negative and a positive. And so if I jump straight to my answers here, I've got x equals 7 and negative 2. But I need to check my answers. All of them might work, none of them might work, one might work, but we don't know until we check. So I'm going to plug in 7 first. That would get me an 8 equals 7 times 7 is 49 plus 15, 50, 65, 64. Square root of 64 is 8. Okay, so 7 is good. All right, let's also plug in a negative 2. Okay, so I plug in negative 2. Hold up. Negative 1. Can a square root ever equal a negative? It can't. It's automatically bad. But let's say you don't see that, right? This would be negative 14 plus 15 square root of 1. Is the square root of 1 equal to negative 1? Right? Like even if you keep going, that negative 2 is not good. You have to check or you don't know. So extraneous solutions often occur if an even index ends up being equal to a negative value. That can't happen. That means it's a bad solution. All right, let's take a look at one more. Take a moment to jot this down. We need to do the algebra 1 work first, meaning I need to subtract 1/3 to the other side. I need to isolate the radical. All right, let's do some by hand work. We need a common denominator in order to subtract, so we have 5/3. Okay? All right, let's do the algebra 2 work. In order to get rid of a squared root, we need to square both sides. My radicand is now out, and when we square a fraction, it's power of a quotient, meaning we distribute. So 25/9. Okay? Now it's algebra 1 work. We're going to divide both sides by 3. Wait, we don't like to divide by a value. We like to multiply by the reciprocal. Instead of dividing by 3, we're timesing by 1/3. Yes, we do need to do that. What that gets me is multiplying fractions. When we multiply fractions, we multiply straight across. So I arrive at 25 over 27. Oh my goodness, how do we check to see how we did? Is that true? Does that work? Okay, I'm going to do a little side work here. That means I'm taking 3 times this fraction plus 1/3, and I should get 2, right? Okay, 3 over 1 times 25 over 27, that would be 75 over 27, squared rooted, plus 1/3 equals 2. Well, I can't square root either of those, can I? So we need to reduce both of these. So think of it like this. I'm going to break both of these apart first. I could rationalize right away, but you guys, I'm doing this by hand, and I don't want to multiply 75 by 27. So instead, I'm going to break it up. This would be 9 and 3. This would be 25 and 3. So this gets me 5 square root of 3. This gets me 3 square root of 3. Square roots of 3 can cancel then, so I don't have any radicals left over. So all of that left side became 5/3 plus 1/3 gets me 2. It does. 6/3 equals 2. And so you've got to remember your radical reducing strategies and information in order to check that answer, especially with no calculator. All right, so those were just some examples on solving radical equations. Make sure possibly to rewatch this video with sound if you haven't yet, and just reevaluate. Sometimes when you're writing so fast, it's easy to miss things. Always check out Google Classroom to see what the task is, and maybe stick around this video to see if what's next will help you with your task. All right, so if you've been listening to my video and you're continuing on, take a look, as this might be one of your homework problems. Let's go through 2 cars traveling the same speed side by side on a road, right? I'm a visual person, so you don't have to draw this, but I'm thinking about 2 cars, right? Same speed, side by side. They slam on their brakes and begin skidding to a halt at the same time. The brakes on the first car are working at top efficiency, while the second car's brakes are only at 70% efficiency. So that means the first car, if it's top, will stop sooner than the second car, correct? If the second car came to a halt 42 feet after the car with the better brakes, what distance did it take each car to come to a halt? Meaning we're trying to find that initial distance. And what speed were the 2 cars traveling? Well, the same speed, but we don't know what it is. The coefficient of friction for the road is 0.6, right? Every road has a different friction. Are we talking gravel, a poorly maintained road, a well-maintained road? That affects as well. Now, if you are looking at your homework, what you'll notice is the formulas are given to you. So take a look, okay? Here are our formulas. The formula states we need to include this 30. Okay. F stands for the coefficient of friction. D stands for the distance. N stands for the efficiency. And that will calculate the speed. So I've got it written twice here because we have 2 different cars, right? So let's say on the first car, I don't know its speed. Copy everything else. The road's friction was 0.6. The distance it's traveled, I don't know. And the efficiency, wait, the first car had great, perfect top efficiency, meaning 100% efficiency. 100% is written as a 1. So let's talk about the second car. Okay, let's compare. I don't know the second car's speed. The friction of the road was the same, 0.6. The distance, wait a second. I don't know the distance, but I know it's 42 feet more than the other car. And the efficiency was 70%. Well, we don't write 70% in math problems, right? We write 0.7. Okay, before you worry about how to compare these 2, let's just reduce what we can reduce, okay? So S equals, I'm going to have a single variable, right? But I can take care of all the numbers. So let's take 30 times 0.6 times 1, and that gets me 18. That looks much cleaner, right? Let's do the same thing to the right side. Ooh, this is a little tougher. I've got 3 numbers here, so let's multiply those. 30 times 0.6 times 0.7. That's 12.6. Oops, 0.6. And it's outside of these parentheses. And so what do I need to do those parentheses? I need to distribute that in. So let's distribute. That would be 12.6D plus, let's take 12.6 times 42 as well, 529.2. All of this is still under a radical. Okay, we simplified as much as we could. Now let's talk about the comparison. They were going the same speed. So what do we know about these speeds? They're equal. And guess what? If they're equal, this is equal to this. We just created a radical equal to a radical. Let's solve. If I solve, this looks like our example 2 in our notes. To get rid of a square root, we would square both sides, which just creates an Algebra 1 level equation. So let's take 18, subtract 12.6, because we want to kick that to the other side. That's 5.4 times d equals 529.2. And then we need to divide 529.2 by 5.4. That gets me a distance of 98. Distance. What's our label if you look in the problem? Feet. Feet is our label. So let's take a look at that. Let's see if this makes sense. So we're saying they were going the same speed and they were traveling a distance, or the first car came to a halt at a distance of 98 feet, which means the second car came to a halt at 98 plus 42. So I haven't quite answered the question, right? So let's go back to the questions. What distance did it take each car to come to a halt? Car 1 was 98 feet. Car 2 was 98 plus 42, so 140 feet. All right, let's take a look at a next question. What speed were the two cars traveling? Well, it was the same speed, but I need to calculate what S is. Well, I know what D is, right? I know what D is, so let's calculate. The speed is whatever the square root of 18 times 98 is. So yeah, you definitely need your calculator for this. It's going to be a crazy number. I'm going to take the square root of 1,764. So get out those calculators. I need to get mine out as well. Oh my goodness, I did not plan for this. Let's take the squared root of 1,764, which gets us an answer of 42. It's perfect. The speed is 42, and we're talking typical speed label, miles per hour. Does that make sense? It does, right? 42 miles an hour and slamming on your brakes, like that makes sense. Now, if you got a negative, you'd be wrong. If you got a speed of 300, you'd be wrong, right? We're talking regular, real world. And so I now have answered all three questions. Car 1's distance, car 2's distance, and both cars' speed. So again, use the formula given to you, set things up, and then solve an equation using the properties from this lesson. Now you should be good to go. The other questions, you can base them off of this question. And until next time, have a good one.